So E is a constant, so I'm going to keep it outside. I don't want it in the problem. The top prime is 1 times the denominator minus the top times the denominator prime, 2 r plus r, and when I differentiate r plus r is 1 divided by r plus r to the 4th power. E squared stays outside. I'm going to factor out r plus r. So an r plus r is left inside. This is gone, minus 2r. Any questions so far? Is this okay? Okay. So then I have e squared. R minus 2r is equal to be negative r. So negative r plus r divided by r plus r to the 3rd power. When I said p prime of r equal to 0, I get that r equals little r.
I just so little r. I just changed it to c, so I don't get confused between the r's.
E? Oh, okay, that's fine. That's fine. So then r, p prime of r, and p of r. So now r and r are positive values because they are resistance. It cannot be minus ohms, right? So, and this is a positive number. This is going to be a positive number. This is all positive here. So this is 0. And since it's a negative slope, a linear function with a negative slope, positive, 0, negative. So positive, 0, negative. Now, when I go back to the function and I plug in r here, I have e squared. So p of little r will be e squared times r over little r plus little r is 2r squared will be 4r squared. So I will simplify. So this will be e squared over 4r. Now, this means going up, and this means going down. I really don't need to determine anything here, because r cannot be anything but between 0 and infinity. So when r is 0, if you want to determine that, when r is 0, this is 0. And when r is infinity, I have to, this is infinity squared, but there is no such thing. There is no need to go that far. Okay, so it will be 0, but I can't really have 0 there, and I can't have infinity either. So all I was suggesting here to show is that indeed when uppercase r equals lowercase r, p of r is maximum. And the maximum is e squared over 4r. So the maximum value of the power is e squared over 4r, and when uppercase r equals lowercase r. Any questions on this? Is this clear? Okay, let's look at an object with a weight such and such.
Number 42.
Yes, 42. For number 42, you don't need my help. An object with a weight W, so it's a positive number, is dragged along a horizontal line by a force acting along a rope attached to the object. If the rope makes an angle theta with a plane, then the magnitude of the force, F, and I am waiting to put the variable in there. Mu W over mu sine theta plus cosine theta. There must be only one variable, and let's read again. W is the weight, fixed. Mu is a constant, fixed. for what value of theta is f the smallest? So what does this function depend on?
Theta.
Absolutely, that's the only variable, theta. Okay, so please find the absolute minimum of this function. Allow me to give a hint. I recommend changing the function into this. This is what I would have done, but you can differentiate without changing it like that also. But I think it's slightly more difficult. Do we need more time? Yes, you will. Okay, so this is a constant. It stays outside, mu w. I bring down the power, mu sine theta plus cosine theta to which power?
Negative.
2 multiplied by the inner function prime.
Mu cosine theta minus sine theta.
Good. So now if you rearrange all this, because we have to now, you will get this. Negative mu w mu cosine theta minus sine theta, everything over mu sine theta plus cosine theta squared. Do you all agree with this fraction? So now f prime of theta equals 0 means this cannot be 0, this cannot be 0, this can never be 0. What can be 0? So I move and divide by cosine. So mu equals sine over cosine, which is tangent theta. So how much is theta? What do I apply to both sides to get theta? Correct. So arc tangent mu. This is not enough, however. So I have theta, which is arc tangent mu. I have f prime of theta, and I have f of theta. I have to go back and study the sign of all this. But I know that this is all positive. So I'm going to plug in 0. When I plug in 0, this is 0, this is 1, and this is negative mu.
Oh, okay, yeah, I saw the negative. Oh, okay.
Right? So it's absolute minimum. So for what value of theta is f the smallest? Theta must be arctangent mu. Whatever mu is, arctangent mu will give us the minimum force. Any questions? Okay, let's work on last one, 33. The top and bottom margins of a poster are each 6 centimeters. So this is a poster. This is 6 centimeters. This is 6 centimeters. And the side margins are each 4. 4 centimeters. If the area of printed material on the poster is fixed at 384, yes. Find the dimensions of the poster with the smallest area. So this is the poster, this is the printed area. So we want to find find the dimensions of the poster with the smallest area. I'm going to denote this by x, and I'm going to denote this by y. And I have an equation right on the top of my first thought. What is the equation right away? So 384 equals xy, correct? Now I want the area of the poster. Can anyone express the area of the poster? Because that's what I'm interested in now.
Yeah, the poster is x plus 8 times y plus 12.
Do you all agree with this? So this is x plus 8, and this is y plus 12. Okay. Now I'm in trouble in the sense that I can't have two variables in here, right? So I have, when I distribute, I have xy plus 12x plus 8y plus 96. Yes, I will replace this by 384. So I have 12x plus 8y. So 384 and 96, 480, I think. So plus 480. However, I do have a problem, and the problem is that it's a function of two variables. But I have an equation that I can use. Which variable you want to get rid of? I never really like to get rid of x, but sometimes I will get rid of x. But in this case, I'm going to say y equals 384 over x. So now I finally have a of x, which is 12x plus, how much is 8? I can multiply 384. After 8 p.m. I can multiply. I'm kidding. I got 3072 divided by x and plus 480. From this moment on, you don't need my help. What are you going to do? And then set it equal to 0. Very good. Let's do just that. So after you differentiate, you should get 12 minus 3072 over x squared, right? Find the least common denominator. You have 12x squared minus 3072. Cross multiply whatever you want to do. You get 16. I should get plus or minus, but since we are talking about centimeters, I can get plus or minus, right? So if x equals 16, it appears that y will be 384 divided by 16, and I get 24. However, this means nothing till I show, right? I have to show this. So this is 16 and this is 0. And this is a quadratic function. This is always positive, and it has solutions negative 16 and 16, but it has a minimum. So it's negative and positive. You can plug in a number if you want. If you plug in 0, you'll see it's negative. So this is the absolute minimum. And now if I'm asked to find that absolute minimum, I will find it as a of 16, which is 12 times 16 plus 3072 over 16 plus 480. And I will calculate this. 12 times 16 plus 3072 divided by 16 and plus 480. So 864 squared centimeters. So this is the absolute minimum.